We now discuss the solution of a problem from the section Sequences and Series. This problem is on infinite geometric series. This question has appeared in the joint entrance examination main held on 28th June 2022 in the second shift. The given question is, let for n is equal to 1, 2, etc. 50 and Sn be the sum of the infinite geometric series whose first term is n square and whose common ratio is 1 by n plus 1 whole square. Then the value of 1 by 26 plus sigma n is equal to 1 to 50 in brackets Sn plus 2 by n plus 1 minus n minus 1 is equal to. We are given n is equal to 1, 2, 3 up to 50 and given Sn denotes the sum of the infinite geometric series whose first term is n square and common ratio is 1 by n plus 1 whole square. Then required to find the value of 1 by 26 plus sigma n is equal to 1 to 50 in brackets Sn plus 2 by n plus 1 minus n minus 1. Let's now discuss the solution of the problem in detail. We have n is equal to 1, 2, 3 up to 50 and Sn denotes the sum of the infinite series with the first term a is equal to n square and common ratio r is equal to 1 by n plus 1 whole square. And observe that the common ratio r is less than 1. Then Sn is equal to a by 1 minus r, that is equal to a is n square by 1 minus r, 1 by n plus 1 whole square, and take the LCM in the denominator and simplify. You will get n square into n plus 1 whole square by n plus 1 whole square minus 1. Now that is equal to n square into n plus 1 whole square by n plus 1 whole square is n square plus 2n plus 1 and minus 1. Plus 1 minus 1 cancels and take n common, n into n plus 2. And there is a common factor, both numerator and denominator, an, cancelling that one, we will get n into n plus 1 whole square by n plus 2. And this needs further simplification, but how to proceed, that we will do when we take into Sn. So 1 by 26 required to find the value of 1 by 26 plus sigma n is equal to 1 to 50 in brackets Sn plus 2 by n plus 1 minus n minus 1. That is equal to, for Sn we write n into n plus 1 whole square by n plus 2. We continue in the next slide for further simplification. That's what we have. Great. Now this is equal to 1 by 26 plus sigma n is equal to 1 to 50 n into n plus 1 whole square is n square plus 2n plus 1. That we have written as n into, in brackets, n into n plus 2 plus 1. That is n square, n into n square plus 2n plus 1 by n plus 2. Now simplify, you will get n square into n plus 2 by n plus 2, that is n plus 2 cancels, n square, and you are having n into 1, n by n plus 2. So look at this term only, the remaining terms are as it is, and that is equal to n square plus n by n plus 2. And this red one, what we have written, it can be written as n plus 2 minus 2 by n plus 2. n plus 2 by n plus 2 is 1 minus 2 by n plus 2. So that red term can be written as this way, 1 minus 2 by n plus 2, the remaining terms as it is. Plus 1 minus 1 cancels, and rewriting the terms, 1 by 26 plus sigma n is equal to 1 to 50, n square minus n plus 2 is taken common between these two, and we get 1 by n plus 1 minus 1 by n plus 2. Agreed. Now, the sigma n square value we know, sigma n value we know, and 2 times sigma of this one can be found out, and this is called the telescoping series. And this is equal to 1 by 26 plus sigma n square minus sigma n plus 2 times sigma 1 by n plus 1 minus 1 by n plus 2, where the sigma runs over n is equal to 1 to 50. And this is equal to 1 by 26, sigma n is equal to 1 to 50, n square is 50 into 51 into 2 times 50 plus 1 by 6. What's the formula? N into n plus 1 into 2n plus 1 by 6 minus sigma n is equal to 1 to 50 n. That is the sum of the first 50 natural numbers is 50 into 50 plus 1 by 2. N into n plus 1 by 2 plus 2 into n is equal to 1. It is 1 by 2 minus 1 by 3. N is equal to 2. It is bracket 1 by 3 minus 1 by 4. N is equal to 3. 1 by 4 minus 1 by 5. And n is equal to 50. 1 by 51 minus 1 by 52. Observe that. Minus 1 by 3 cancels plus 1 by 3. Minus 1 by 4 cancels with plus 1 by 4. Like that we continue. And minus 1 by 51 cancels with plus 1 by 51. And what will be left in such series is the first term minus the last term. The first term minus the last term, that is 1 by 2 minus 1 by 2, 1 by 52. Such series are called telescoping series. Telescoping series. So this will be 1 by 26 plus 50 into 51 into 101 by 6, agreed, minus 50 into 51 by 2 plus 2 times first term 1 by 2 minus the last term 1 by 52. And this is 1 by 26, and this one we have simplified, that is 42,925 minus this one is 1275. 2 into 1 by 2 is plus 1, and 2 into minus 1 of 52, 1 by 52 is minus 1 by 26. Minus 1 by 26 plus 1 by 26 cancels, and simplify this one, you will get 42,925 minus 1275 plus 1, that is, after simplification, you will get 41,651. So that is your answer. That is 1 by 26 plus sigma n is equal to 1 to 50 in brackets Sn plus 2 by n plus 1 minus n minus 1. The value is 41,651. That is your answer. The answer to this question is 41,651, and that is the detailed discussion of the solution of the problem from the section sequence and series, and the problem is based on the concept of infinite series. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.